There are a lot of mysteries in the universe. Our minds are filled with a large number of riddles every time we gaze above. What's up there, and what is beyond the visible stars? There is, in reality, a region of space where humans' eyes can't detect anything. That location, known as a black hole, has such an extreme gravitational attraction that even light cannot make its way out. The only way for humans to perceive the existence of a black hole is through its influence on the space immediately adjacent to it. For instance, observers have observed black holes ripping and devouring stars that wander too close. So, how does a black hole look in outer space, and where are they located? Continuing watching this video and learn everything that you need to know about black holes today. Also, if you're new to this channel, make sure to subscribe and hit that bell icon so you won't miss any of our future videos that we upload. Getting back to the video, it's generally accepted that a supermassive black hole can be found at the heart of nearly every major galaxy. These black holes have millions or billions of times the mass of the Sun, and they swallow any matter from their surroundings that gets too close. The existence of black holes was initially predicted by Albert Einstein in 1916, based on his general theory of relativity. In 1967, American astronomer John Wheeler created the phrase black hole to describe these objects. Black holes were just a theory for a long time, but now they are becoming real. The first black hole ever found was Cygnus X1, which is in the Milky Way in the constellation of Cygnus, the Swan. According to NASA, astronomers first identified the black hole in 1964, when a sounding rocket picked up X-rays coming from the heavens. In 1971, astronomers tracked the X-rays to a brilliant blue star that orbited a mysterious black object. Evidence for X-ray emissions was taken as proof that a black hole ate the star's material and caused its death. Scientists have confirmed only a few supermassive black holes, but the cosmos may possibly contain billions of these gravitational monsters. In theory, if enough stuff is compressed into a tiny enough region, it will generate such a tremendous gravitational field that nothing, not even light, can escape. That is the fundamental concept of black holes. And it is so odd that for so many years people felt that they couldn't possibly exist in reality. However, we now know that the universe is packed with them, possibly one for every 10 visible stars. Some of these black holes are truly massive, with masses of millions of times that of our Sun. Moving forward, let's talk about the size of the supermassive black holes. It is not feasible to directly witness a black hole because, as the name suggests, they do not release any light or other forms of radiation into their surroundings. However, they are detectable because of the gravitational effect that they have on stars that are visible in their surrounding area. These stars circle around the black hole at a considerably faster rate than they would around a normal object of comparable size. Astronomers are able to calculate the mass of a black hole by determining the speed of stars that orbit close to it. According to NASA, this is how astronomers were able to determine that the black hole at the heart of our very own galaxy has a mass of almost 4 million times greater than that of our Sun. Now you have an idea about black holes and that they aren't normal things like planets and all the other stuff in the cosmos. In fact, they're like space gangsters who can destroy anything that tries to come close. Sometimes, rather than devouring anything that goes close to them, the black holes at the centers of most galaxies merely give away their existence through minor effects on nearby stars. This is because they are so massive that nothing can escape their gravitational pull. However, the supermassive black holes in an active galaxy behaves very differently than it does in a passive galaxy. When a swirling accretion disk of rapidly rotating gas and dust is present around a black hole, matter will continually spiral down into the depths of the black hole. During this process, it gives off huge amounts of energy, which can sometimes make it so bright that it makes the rest of the galaxy look dim. Now you guys must be thinking, where do black holes come from and, well, how do they form if they originated from dead stars? Well, it's a complicated phenomenon that consists of many hypotheses. Black holes are frequently portrayed as enormous cosmic vacuum cleaners that voraciously consume other material until there is nothing left. If that was how genuine black holes worked, then there would be no mystery as to where the supermassive sort originated from. After an ordinary black hole had formed as a result of the collapse of a star, it would simply continue to expand and grow until it reached an immense size. However, true black holes do not consume matter in this manner. Rather, they merely attract it using the same principle of gravitational attraction as a typical object of the same mass would. The fact that they are so compressed contributes to their remarkable character, as does the fact that their gravitational pull becomes stronger with decreasing distance. Therefore, it's feasible for an orbiting object to stray into a location where the gravitational pull is extraordinarily intense. The gravity of a black hole, on the other hand, returns to its usual value at greater distances. However, if a black hole is unable to draw in stuff from a great distance, one might wonder how it could ever expand to such a gigantic extent. Although there are a number of intriguing hypotheses, no one knows a solution to this question at the present time. It is common knowledge that some black holes are capable of consuming fresh matter. For instance, this is what occurs in the assertion disks of active galaxies. The evidence of gravitational waves, which have been observed on a consistent basis ever since they were discovered in 2015, demonstrates that, on occasion, two black holes will collide with each other and merge into a single larger black hole. This is something that we know for a fact because gravitational waves have been observed. Nevertheless, assertion and mergers, despite the fact that they surely contribute to the answer, are not sufficient on their own to explain the observable evidence of supermassive black holes. This is due to the fact that we are aware of the formation of the earliest active galaxies at a very early stage in the history of the universe. These galaxies must have been propelled by central black holes. For example, it's hypothesized that a supermassive black hole, 1 billion times the mass of the Sun, existed in one galaxy more than 12 billion years ago, or nearly 90% of the way back to the Big Bang. It is possible that the stellar life cycle, which is so important to the standard model of black hole formation, had nothing to do with the creation of the oldest supermassive black holes. Instead, it's possible that they came into practically instantly as a result of gravitational collapses of a massive cloud of gas, one that already contained enough matter to equal the mass of millions of stars. According to this theory, the formation of a direct collapsed black hole of this kind would have required approximately 150 million years. This is comparable to the blink of an eye in terms of the cosmos. The concept of primordial black holes, which are thought to have been produced by the Big Bang itself, is brought up in another one of the hypotheses. These are sometimes suggested as a possible explanation for dark matter, and it is widely considered that they were quite small in size when they existed. On the other hand, it's possible that they were the seeds from which today's supermassive black holes evolved from their humble beginnings. And last but not least, is it possible that time moves more slowly within a super black hole? It is true that high gravitational pressures, such as those experienced while approaching a black hole, slow down time. But you can only be aware of this by comparing your experiences to those who are far away from the black hole. You will notice a faraway friend speeding up rather than feeling slowed down. They will notice that you have slowed down rather than feeling that they have sped up. The closer you get to a black hole's event horizon, the faster you see your companion. But time would feel the same to you as it does now. You can only observe the difference when comparing it to a far object. Well, that's all for today's video. What do you think about today's video topic? What are your thoughts about black holes and its origins? Do you think that they are older than the universe itself or not? Tell us all about your views in the comment section below.